Hello friends, this is Suresh. I will talk about common loss functions, MAE that call L1 loss, MSE that call L2 loss, and cross entropy. I will start with regression laws. So there are most of the cases people are using, and in general use case that called regression, get classification. So that called regression laws and classification laws. So I will start with regression laws. So first regression laws that called L2 laws, you heard about that mean square error function, the quadratic loss function, and this is the mathematic formula for mean square error function. So n is the number of training example, ith is the ith training example in the data sets, and yi is the called ground truth level for ith training example, and y hat that called prediction for the ith training example. So MSE is the difference square, like it's a summation of squared error, and divide by all the total number of the samples. So that is called mean square error function. So and in this mean square error function where we can apply it, so it's all the depend on. So I will talk about the advantage of mean square error function. So here for example the actual prediction, for example here actual ground truth and prediction. So if the difference between uh, ground truth and prediction, like for example actual ground truth is 1 and prediction is 0.001. So and then we take a square of this subtraction. So if if the prediction so much far from actual value, so like actual ground truth, so it will penalize heavy. So 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 we can use where outlier in our data, and like we need such kind of like penalizations, like we need to heavy penalizations here. So that is the advantage of here, so it would penalize. So if you like I will talk about the next regression laws that called L1 laws. So in annual laws, like mean absolute error, in here similar kind of mean square error function. So but the difference between the square error and that MAE that called annual loss, there are we are not doing square of that error. So we are taking the absolute value. So whatever positive and negative value we are getting that error, and then we will put absolute value and summation of all of the error and divide by number of the samples. So it's the better than, and it's depend on the outliers in the data. So if outlier so much like not it's in particular constant, so we can use MAE. So that's the advantage and use cases of MAE. Now I will talk about the mean bias error. So mean bias error is it's just difference between m mean absolute error. There in mean absolute error we are taking as a absolute value of error, but here we are not taking absolute value. So it can be a negative value, it can be a positive value. So it give is the direction of negative bias, a positive bias of. So that's if we are taking the mean bias error like negative or positive. So there we have to use here. And and in MAE and MSE, in MSE it will give the direction of the data and direction of the the value, but here you are not square, you are using the squared value, we are getting the direction, but here not we are getting the direction. So that's the different comparison with three type of regression laws. Now I will go through the cross entropy laws. So that call another negative log likelihood. So in talks generally in terms of entropy. So entropy in mathematical terms, like whatever we have actual value, like actual prediction, actual probability, and predicted probability. So y is the actual and y hat is predicted. So and 1 minus y actual and log 1 minus that y hat. So uh, that's the mathematical function of cross entropy. So here, if we thinking about, we just analyze the cross entropy function, then we found that if yi this equal to 1, then this part, second part, completely 0, but like 1 minus 1 is equal to 0. If we think about y is equal to 0, this part is 0, then this part is 0, then this part completely, like yi is equal to 0, then this part completely 0, and this we are getting this value like log 1 minus log 1. So here, that is the uh, analogy of here. So here, if you can see here directly, if predicted value is so much far from actual, so it will, the cross entropy laws penalize heavily in the prediction that are confident. So, and another thing, like if we, prediction are confident and wrong also, so prediction are confident but wrong, so it will penalize heavy. That's why, like that's the, the positive points of this cross entropy laws. So generally it will use in the classification problems, so like class 0 and class 1. So for example, actual ground truth is class 0 and it's confident that class is 1, so it's penalized heavily, right, using this. So the second part, so the both part maintain. That's why cross entropy laws were most popular in the classification problems. So this is all about the cross entropy laws. So that's all about this. And now I'll summarize what we did. So uh, we did the regression laws. In regression laws, L2 laws, L1 laws, and like mean bias error. And then I talked about cross entropy laws and the advantage of the cross entropy laws and how it's work. So thank you for watching the video.